Bismillahirrahmanirrahim. Assalamu alaikum. I am Dr. Fazullah and you are watching Easy Mathematics. Let us learn the type of ordinary differential equations which are not homogeneous, but they can be reduced to homogeneous form. Equations reducible to homogeneous form. There are some particular type of ordinary differential equations which are not homogeneous, but they can be reduced to the homogeneous form. These equations have the form of equation 1. By equation 1, we mean in this equation, there is a constant C1 in the numerator and C2 in the denominator. If we don't have these two constants, the remaining is a homogeneous ordinary differential equation. Now, if we see an equation of this type, that equation can be reduced to the homogeneous form. In this lecture, we shall learn the method for solutions of such type of equations. Let us see some examples of these type of equations. In example number 1, we have a differential equation dy by dx is equal to 2x plus 3y plus 4 divided by 4x plus 9y minus 1. This equation is not homogeneous, but it is of the form 1. So we can reduce this equation to the homogeneous form. By of the form 1, we mean there is a constant plus 4 like plus C1 and a constant minus 1 like C2. So if we don't have these two constants, the remaining is homogeneous. So this equation is of the form 1. And now let us see another example of such type of equations. Example number 2. In this example, we have a differential equation dy by dx is equal to 7x plus 11y plus 12 divided by 3x plus 4y plus 1. This equation is not homogeneous, but it can be reduced to homogeneous form because it is of the form 1. By of the form 1, we mean there is plus 12 in the numerator and plus 1 in the denominator. If we don't have these two constants, the remaining is homogeneous. So it is of the form 1 and it can be reduced to the homogeneous form. Let us see another example. In example number 3, we have a differential equation dy by dx, which is equal to 11x plus 13y plus 15 divided by 4x plus 7y plus 6. Now this equation is not homogeneous, but it is of the form 1, so we can reduce this equation to the homogeneous form. Method of solutions. To solve such type of equations, we have two cases. Case number 1, if a1 divided by a2 is equal to b1 divided by b2, then we have to put a1x plus b1y is equal to z. And as a result, we shall get a separable equation. Case number 2, if a1 divided by a2 is not equal to b1 divided by b2, then we have to put small x is equal to capital X plus h and small y is equal to capital Y plus k. After these substitutions in 1, we shall get a 1x plus b1y plus a 1h plus b1k plus c1 divided by a 2x plus b2y plus a 2h plus b2k plus c2. Then we will put a 1h plus b1k plus c1 equal to 0 and a 2h plus b2k plus c2 equal to 0 to obtain the value of h and k. And as a result, we will get a homogeneous equation. So for case 1, we have to remember this substitution, and for case number 2, we have to remember these substitutions. Let us solve some questions to explain the method. We can see that equation number 2 is of the form of equation number 1. So 2 is reducible to homogeneous form. Now here a1 is equal to 3 and a2 is equal to 3. So 3 by 3 is equal to 1. Similarly, we can see that b1 is equal to -4 and b2 is equal to -4, which is equal to 1. So we can see that a1 over a2 is equal to b1 over b2. So we can use case number 1 to solve equation number 2. Let us put 3x minus 4y is equal to z. Now we need the value of dy by dx. So let us simplify this equation. So if we simplify this, we can get that this is y is equal to 3 by 4x minus 1 over 4 z. Differentiating both sides with respect to x, we have dy by dx is equal to 3 by 4 minus 1 over 4 dz divided by dx. Therefore, equation number 2 becomes, after putting these values, we have 3 by 4 minus 1 by 4 dz over dx is equal to z minus 2 divided by z minus 3. Now let us simplify this equation. 1 over 4 dz divided by dx, which is equal to z minus 2 divided by z minus 3 minus 3 by 4. Now if we take the LCM and simplify this equation, we get z plus 1 divided by 4 into z minus 3. Cancelling 4 from both sides, we have minus dz divided by dx is equal to z plus 1 divided by z minus 3. And now it is a separable equation. So let us separate the variable. So if we separate the variable, we have z minus 3 divided by z plus 1 into dz is equal to minus dx. Now we can integrate both sides, but from the left hand side we can see, we can write this z plus 1 minus 4 divided by z plus 1 dz, which is equal to minus dx. From here we can get 1 minus 4 divided by z plus 1 into dz is equal to minus dx. Now integrating both sides, we have integration of 1 dz minus 4, integration of 1 over z plus 1 dz is equal to minus integration of dx. From this we can get z minus 4 ln of z plus 1, which is equal to minus x plus c1. Now we can re-put the value of z. So z is equal to 3x minus 4y. If we re-put this value, we have 3x minus 4y minus 4 ln of 3x minus 4y plus 1 is equal to, now we can bring minus x to this side. So we have plus x is equal to c1. Now if we further simplify this equation, we have 3x plus x, this is 4x. So we have 4x minus 4y minus 4 ln of 3x minus 4y plus 1 is equal to c1. Dividing each term by 4, we have x minus y minus ln of 3x minus 4y plus 1 is equal to c, where c is equal to c1 by 4. And this is the required solution of the given problem. Question number 2. Solve the ordinary differential equation number 1. We can see that this is an equation reducible to homogeneous form. To solve this differential equation, here a1 divided by a2 is equal to 1 divided by minus 1, which is equal to minus 1. And b1 divided by b2 is equal to 1 divided by 1, which is 1. So we can see that a1 divided by a2 is not equal to b1 divided by b2. So we can use case number 2 here. Now put small x is equal to capital X plus h and small y is equal to capital Y plus k. And from here we can get dx is equal to d capital X and d small y is equal to d capital Y. So equation 1 becomes dy over dx is equal to x plus h plus y plus k minus 1 divided by minus x minus h plus y plus k minus 3. And now we simplify this to get dy over dx is equal to x plus y plus h plus k minus 1 divided by minus x plus y minus h plus k minus 3. Let us say this is equation number 3. Now put h plus k minus 1 is equal to 0 and minus h plus k minus 3 is equal to 0. This is equation 4 and let us say this is equation number 5. Now adding equation 4 and 5, we have 2k minus 4 is equal to 0, which gives k is equal to 2. Now putting k is equal to 2 in equation number 4, we have h plus 2 minus 1 is equal to 0, which gives h is equal to minus 1. Therefore, equation 3 becomes dy over dx is equal to x plus y divided by minus x plus y, which is a homogeneous ordinary differential equation. It is homogeneous ordinary differential equation. And now to solve this homogeneous differential equation, we put y is equal to vx. And from here we get that dy over dx is equal to v plus x dv divided by dx. So putting these values in equation number 6, we get. So let us solve the remaining question. Here I have to just separate the screen for simplicity. And now we get from equation number 6 that v plus x dv divided by dx is equal to x plus vx divided by minus x plus vx. Taking x as common and then simplifying, we have 1 plus v divided by minus 1 plus v. Now taking v from the left hand side to right hand side, we have x dv divided by dx is equal to 1 plus v divided by minus 1 plus v minus v. Let us take its LCM. So its LCM is minus 1 plus v. We have 1 plus v and minus, this is plus v and minus v square. So if we further simplify this, we have 1 plus 2v minus v square divided by v minus 1. Now from here we get dv over dx is equal to, let us take minus as common. We have v square minus 2v minus 1 divided by v minus 1. And now it is variable separable. So it is separable equation, just separating the variables. From here we get that v minus 1 divided by v square minus 2v minus 1 is equal to minus 1 over x dx. And here we have dv. Now just integrating both sides. So if we integrate v minus 1 divided by v square minus 2v minus 1 dv, which is equal to minus integration of 1 over x dx. Now differentiation of this denominator is 2v minus 2. So multiplying and dividing by 1 over 2. And now we have 1 over 2 ln of v square minus 2v minus 1 is equal to minus ln x plus ln of c1. And now let us multiply each side with 2. We have ln of v square minus 2v minus 1 is equal to minus 2 ln x plus 2 ln c1. And now we can take this 2 in the power, which is rule of law. So we have, this implies ln of v square minus 2v minus 1. And now this becomes plus ln x square. This is equal to ln c, taking c equal to c1 square. And now again by using the rule of logarithm, we have log x square into v square minus 2v minus 1 is equal to ln c. Let us cancel ln from both sides. So now we have to separate the screen once again. Let us see what will happen in the next step. Here we have to re-put the value of v now. So we know that y is equal to vx. So v is equal to y by x. So putting this value, we have x square into y square divided by x square minus 2y divided by x minus 1 is equal to c. Multiplying this x square, so we have y square minus 2xy minus x square is equal to c. Now again, re-putting the value of capital Y and the value of capital X. So we know that capital X is equal to x minus h. And we know that h is, let us see the value of it, which is minus 1. So this is x plus 1. Similarly, capital Y, this is equal to small y minus k. And we know that the value of k is 2. So we have y minus 2. Let us put these values in equation number star. So star becomes, we have y minus 2 whole square minus 2 into x plus 1 into y minus 2 and minus x plus 1 whole square is equal to c. And now if we simplify this equation, we get y square minus x square minus 2xy minus 6y plus 2x plus 3 is equal to c. And this is the required solution of the given problem. That's all.